Hello everyone. Today I wanna discuss about algorithms for each of the specified running times. In the first, I wanna talk about O1 time complexity. So what is it? It have a constant time execution, meaning the time required to complete the operation remains constant regardless of the input size. For example, accessing an element in an array by index, assigning a value to variable, or performing basic arithmetic operations. In here, you can see this code. So, to prove that the given code has a time complexity of O1, we needed to analyze its behavior in terms of the input size. Array length. In this case, the input size is constant because the array is of fixed size 5 elements. So let's break down the code. In this line, initialize an array of size 5 and the size of the array is constant. And its lines calls the getFirstElement method with the array as an argument. In this line, getFirstElement method simply returns the first element of the array R0 since the array size is constant and it doesn't depend on the input. Accessing the first element of the array takes a constant amount of time. So, therefore, the time complexity of accessing the first element of the array is O1 because it doesn't depend on the size of the array. It's a constant time operation. So we can say the rest of the code doesn't involve any loops or iteration based on the input size, reinforcing the O1 time complexity. In conclusion, we can say our code can work at according O1 time complexity. Next, we want to talk about ON time complexity. It's a linear time complexity means the running time of the algorithm grows linearly with the size of the input. For example, linear search in an unsorted array where you have to iterate through each element until you find the target. For example, in here, as you can see, I give arrays and we need to find maximum element in array. So we have arrays and the method. We give an integer max element which it's equal to find maximum element array to our method. So how our method can work it? The method starts by initializing a variable maximum with the first element of the array R0. This is a constant time operation, O1, as you remember. So in the loop, we need to write and give an integer element. It's like our arrays. So if element larger than maximum will be equal to element. So what is it that's mean? The method then enters a loop that iterates through each element of the array exactly once. The loop's time complexity is directly proportional to the size of the input array n, making it O(n). The loop compares each element to the current maximum and updates maximum if a larger element is found. So, on a return after the loop completes, the method returns the maximum element. This is a constant time operation, O1. The overall time complexity of the find maximum element, this method, determined by the determinant factor, which is a loop iterating through each element of the array. So in the end, we can say the time complexity is O1, where n is the size of the input array. So let's run it, this code. You can see, yeah, we got a correct answer. So we can see the time complexity O(n) can work at this code. Now we're gonna talk about next time complexity. It's called O and log n. So what is it? Algorithms with O and log n time complexity often involve divide and conquer strategies commonly seen in efficient sorting algorithms. For example, merge sort and heap sort examples where the input is repeatedly divided and then merged or combined in a way that maintains a logarithm's factor. So we have arrays and we need to sort this. So for it, we're gonna use a merge sort. So what to do? In a main method, this we here we initialize an array R and print it. Then we call the merge sort method and to sort the array using the merge sort algorithms. So in a merge sort method, these lines checks if the array has more than one element. If it has only one or zero elements, it's already considered sorted and the method returns. And this line calculates the middle index of this array. These lines created a new array left to store the left half of the original array. System array RO left O mid. This lines copies the left half of the original array to the left array. And the int right, this line creates a new right to store the right half of the original array. And this line copies the right half of the original array to the right array. And these lines recursively call the merge sort method on the left subarray, and this recursively calls the merge sort method on the right subarray. These lines call the merge method to merge the sorted left and the right subarrays back into the original array. In the merge method, this line declares the merge method which merges two sorted subarrays left and the right into the original array. So we're gonna initialize pointers for the left, right, and the result arrays. In the loop, this starts to compare and then merges elements from the left and the right subarrays. This line compares the elements at the current position of the left and the right subarrays. The smaller element is added to the original array and the respective pointers are incremented. So this adds any remaining element from the left subarray to the original array, and this line adds any remaining element from the right subarray to the original array. In the lost method print array, this line declares a method which is responsible for printing the elements of an array. And for this line uses an enhanced for loop to iterate through each element of the array and print it. And we're gonna print it. The line adds a new line character after printing all the elements of the array. So we're gonna run it. As you can see, we got the right answer. So in summary, the merge sort algorithm recursively divides the array into smaller halves, sorts those halves and then merges them back together. The division and the merging steps are repeated until the entire array is sorted. This process ensures a time complexity of O and log n, where n is the size of the input array. The key idea is that each level of recursion processes all elements in the array and there are log n levels of recursion. And the next, it's a O n multiple n time complexity, n square. It's a quadratic time complexity, signifies that the running time of the algorithm is proportional to the square of the input size. For example, we can use bubble sort and insertion sort, where you compare and swap elements in nested loops. And in here, we're gonna sort an array with bubble sort method. So we're gonna initialize an array with some integers values, calling bubble sort and the printed sorted array. In a bubble sort method, this line stores the length of the array in the variable n, and for each, it starts the auto loops that iterates through each element of the array, excluding the lost one. And the second for each, it starts the inner loop that iterates through the unsorted position of the array. So we're gonna write a if this block compares adjacent elements and swaps them if they are in the wrong order, and the in times call rg, this line performs the swap using a temporary variable. So we're gonna run it. As you can see, we got a right answer. So, as the bubble sort algorithm compares and swaps elements in a nested loop, it has a time complexity of O(n) square, where n is the number of elements in the array. The nested loops result in a quadratic time complexity, making it less efficient compared to some other sorting algorithms for large datasets. And the last time complexity is called log n cubic. Cubic time complexity, it indicates that the running time of the algorithm is proportional to the cube of the input size. For example, matrix multiplication with 3 nested loops, where you have to iterate over 3 dimensions to calculate each element of the resulting matrices. Understanding these time complexities helps in choosing the appropriate algorithm for a specific problem based on the expected size of the input data. Algorithms with lower time complexity are generally preferred for larger datasets. And then here, for example, we have 5 just like indexes. So we're gonna create a matrix. It's mean like we will get a long answer. So how it work with this time complexity? And first we initialize variable n with a value of 5. This represents the size of the problem, and you can change it as needed. And the calling cubic time complexity calls the method with a specified value of n. So in the next cubic time complexity examples method, it declares the method with a parameter n, and in the first for each, it starts the auto loop that iterates from i 0 to n minus 1. In the second for each, it starts a middle loop that iterates g from 0 to n minus 1. So in the last for each, this line starts the inner loop that iterates k 0 to n minus 1. And the system output line, this line prints the value of the I, J, and K. The 3 nested loops result in a cubic number of iterations. So we're gonna run it. As you can see, we got a long answer. As you can see, and the first time all 3 points equal to 0, and the second time k and in the second time k it will work in the first time. It starts from 0 to 3. Yes, because we have a 5 and variable 0 to 4. So as each loop can iterate n times, and there are 3 nested loops, the total number of iterations is given by n multiple, resulting in a time complexity. It's a complexity O n cubic, the code will print all combinations of I and gk, demonstrating cubic time complexity. So it's all guys. So thank you for your attention. Today we can work and understand how can work this time complexity in algorithms. So why we need a time complexity? In the first, evaluate the efficiency, compare and assess the efficiency of algorithms, helping us choose the most suitable algorithm for specific tasks. And the second, predict performance, predict how quickly an algorithm will handle increasing amounts of data, providing insights into scalability. And the three, optimize resources, enhance performance. Select optimal algorithms based on specific conditions, saving the time, our computational resource. Develop efficient programs, crucial in arrays demanding high performance, such as large, for example, databases or graphics applications. In summary, we can say time complexity analysis allows us to make informed decisions when selecting and developing algorithms, considering their efficiency and the resource consumption. So, thank you guys. See you next time.